Hello and welcome to the third part of our tutorial series How to Get Started with UOS. In the previous part of this series, we have already seen how to use a UOS device as a PLC. To do this, we downloaded and installed the CODESYS development system on our computer. Installed the corresponding CODESYS package for Weidmüller UOS so that we can use Weidmüller devices and modules in CODESYS. Downloaded the CODESYS runtime from the Weidmüller Support Center and installed it on UOS on a U-control. And created a small CODESYS project to test the installations. We have defined the variables that we need for the PLC program in a global variable list. After all, we use these variables in the actual PLC program, for example for calculations and assignments. In our example, an analog value from the analog input module is converted into a real voltage value in the first line. And the temperature value from the measuring module is divided by 10 in the second line to obtain the real temperature value. In the following, I will show you step by step how to display these values in a visualization. Firstly, we need the controller, in our example a new control M4000, on which the UOS operating system is installed. We have already installed the CODESYS runtime as an app and created a small PLC program. For visualization purposes, we will now install the runtime version of PROCON-WEB Embedded System on the controller. To do this, we reconnect to the control unit and call up the IP address of the control unit via a web browser. The UOS login interface appears. After logging in, we are forwarded to the start page. To install PROCON-WEB ES, we now go to the UOS Control Center. Here we open the App Manager via the menu bar on the left-hand side under Apps. To install a new app, we now click on the Install App button. UOS now connects to the App Hub and then displays all available apps. PROCON-WEB ES is now selected from this list, and after a short version check you can select the current version or an older version from a list in case you are working with an older version of PROCON-WEB Designer. In our example, we will select the latest version that was already offered at the beginning. After a brief check of the settings, this runtime version can now be installed. PROCON-WEB ES is now installed, and then this app also appears in the App Manager. This completes the first step and we continue with the second step, the installation of the PROCON-WEB Designer. Like all Weidmüller software products and documentation, you can easily download this designer from the Weidmüller Support Center. To do this, first call up our homepage weidmuller.com in your browser. Then click on Support Center in the top menu bar. In the Support Center, we now enter PROCON-WEB Designer in the search field. All search results are then displayed. To find the right software in this list, we can apply a filter here, in our case, Software, under Software Downloads. We now select the latest version from the matching items. In our case, we use the download button to download the latest version of the designer and then, if available, the latest patch. These files are now downloaded from the Support Center and can be installed on the PC. The necessary software installations are now complete and we can continue with the next step, publishing the process variables. In this step, we specify in the CODESYS control software which of its variables are to be published. On the one hand, this prevents other programs such as PROCON-WEB from having access to all variables and possibly being able to change them. Secondly, we avoid unnecessarily high data traffic. In this way, CODESYS only provides and transfers the data that PROCON-WEB really needs. To publish variables from CODESYS, we first switch back to our CODESYS project. We have our 4 variables in the global variable list. The top 2 integer values come directly from the analog modules and are of no interest for the visualization. However, the converted real values are interesting, and we want to publish these for PROCON-WEB. To do this, I create a new object in the project tree under Application by clicking on it with the right mouse button, a symbol configuration. In the following window, please make sure that Support OPC UA features is selected and then click on Add. From the symbol list that has now been created, we now select the variables from the Global Variable List, or GVL for short, that are to be published. Here are our 2 real values. OK, the desired variables are now published and can be used by the visualization. This leads us directly to the next step, establishing a secure data connection. Between CODESYS and PROCON-WEB, we want to use the data connection via OPC UA, which is very widespread in the automation sector. In addition, we want to ensure that this connection is also secure against unauthorized third-party access. In this step, we therefore create certificates for a secure OPC UA data connection. To do this, we switch back to the CODESYS project and first establish a connection to the controller. Please double-click on Device to open the device overview. Here we select the Scan Network tab, then select the communication partner and confirm with OK. Now double-click on the shield symbol at the bottom right to switch to the security settings. In the window that now appears, we select Devices. The info list for the devices is initially empty. However, it is filled with information after clicking on the green refresh button. But first, I have to log in to the device for authorization. And then a tree structure appears in the info list showing various categories of certificates for this device. By clicking on Device in this list, a certificate list for the device appears to the right of it. As we can see, the certificate for the OPC server is not available, but we can create one by clicking on the Certificate button. A validity period can now be specified in the Certificate Settings window, with 1 year being the longest duration. Click on OK to create a certificate. The system is now calculating a certificate for the OPC UA server. Now just save the project, generate the code and transfer it to the controller. That's it, and we move on to the next step, reading in process variables in the PROCON-WEB visualization system. So we open the PROCON-WEB Designer and first create a new project by clicking on the New Project icon. We now enter a descriptive name as the project name, for example visu_temperature. This name is automatically used as the file name. As we use the uControl web server for the visualization and also want to store all runtime data for the visualization there, we select Embedded Systems instead of HMI SCADA as the target system. The project is now created and several menu items appear in the project tree on the left-hand side of the screen, including the process connection item and the process variables menu item under it. Double-click on this to display a list of all existing process variables, also called tags. This list is relatively empty, it only contains a few tags that are predefined by the system. To integrate the published variables from CODESYS, we first select a driver for the connection. Click on Driver Selection to open a list of all available drivers. Here we select OPC UA and then configure the connection by clicking on the Connection Selection menu. Firstly, we assign a descriptive name for this connection, for example OPC UA connection. The parameters follow. Firstly, the connection URL. It always starts with opc.tcp://, then the IP address of the controller, here, 192.168.0.101, then colon, followed by the OPC standard port number 4840. We then enter the login name and password for the controller and, in our example, change the read access to cyclic read for continuous, cyclical data transmission. We then confirm the parameter data with OK and also the driver selection. The data connection is now parameterized and we can now import the tags from the controller. Click on PLC Import to open a window for this purpose. In the right-hand part of this window, we first select the desired connection driver. As we only selected OPC UA in the driver selection, only this driver can be selected. Click Add to open the corresponding import window for OPC UA. As the input parameter, we enter the URL of the connection again, opc.tcp://, then the IP address of the controller, here, 192.168.0.101, then colon, followed by the OPC standard port number 4840. We then enter the access data for the control unit again, that means username and password. With these parameters we now try to establish a connection. If you are establishing a connection to CODESYS for the very first time, this will initially fail. What looks like an error here is actually a good sign. It shows that the secure OPC UA connection to CODESYS is working. PROCON-WEB requests data from CODESYS and provides a certificate that is not yet known to CODESYS. Accordingly, CODESYS does not hand over any data. Let's take a look at the security screen of CODESYS. In the Quarantine Certificates folder, we see the certificates that CODESYS does not yet trust and has therefore moved to this quarantine folder. Here we also find the certificate for the PROCON-WEB data import via OPC UA. We know that CODESYS can trust this certificate, so we now move it to the Trusted Certificates folder. From now on, CODESYS will allow data import from PROCON-WEB. We switch back to the PROCON-WEB Designer and try to access the data from CODESYS again. This time the connection is successful because CODESYS allows this connection thanks to the existing trustworthy certificate. The selection window now displays a directory with all the data that the OPC UA server provides for this connection, divided into different categories. Under Device Set we find our uControl M4000 controller. There we find the global variables under Resources, Application. Here in our GVL, that means the global variable list. Finally, the two variables published by CODESYS can be found under GVL. We now select these and click the Reply button to accept this selection. Once we have selected which variables we want to use for the visualization, we read in these symbols by clicking on Read Symbols. A list now appears with the variables that we can transfer or import into our process variable list. We can either import these variables individually, as shown here, or we can mark the entire action column with the Mark Action row button and then open a menu with the right mouse button and import all variables with a single mouse click. This is particularly useful if we have a large number of variables in this list. Let's take a look back at the process variable list. Here we can now see the two tags that we imported from CODESYS. However, the names are too long for me. I don't need the OPC UA path information to use the variables in my Visu project. I will therefore shorten the names by removing the path information. Don't worry, the path information for data communication is still there. They are at the back in the identifier column and should of course not be changed here. So, the data connection is established and all the preparations have been made to create a visualization. In the last step, we want to do exactly this. We create a small visualization in which our two values, namely temperature and voltage, are to be displayed on a monitor. To do this, we select the Start screen in the Designer under Starting Pictures in the project tree, which is then displayed as a gray field in the editing area. To be able to see as much as possible, I now enlarge this area. I now want to change a few properties of this empty Start screen, so I click on it with the right mouse button and a menu with selection options for this Start screen appears. I want to change the properties of the class, that means the template for Start screens, and a window appears with the properties of Start screens. I don't like gray as the background color, I change it to white. Now I adjust the dimensions of the Start screen. With a full HD resolution of the monitor, this is 1920 x 1080, so the Start screen will take up the entire monitor surface. After confirming with OK, the changed properties are applied and now I want to add life to the Start window. Firstly, I need a text to name the temperature value that I want to display. Under Simple Controls I find the icon for text fields. Here I select Constant Text and a Properties window for this text is displayed. I now enter the text to be displayed under Value and change the font to bold with font size 72 under Font, so really bold and big. I confirm the properties with OK and the text is displayed on the Start screen. I use the Fit button to adjust the screen for a better overview and now move the text to the desired position. Now to the actual temperature value. Under Simple Controls, I select Numeric fields and below that numeric digits and the corresponding properties window appears. Under Tag, I now select the variable for the value to be displayed, here, the imported tag for the temperature value. Now I change the font size to 48 under Fonts and the font style to bold. I now select a nice blue instead of black as the text color. In the preview window, I can see that 2 digits are displayed after the decimal point by default. I want to change this to 1 digit. With Define Format activated, I can now set the decimal digits to 1. So, that's it. Now I'll set the display value to a suitable position. Below this value, I leave some space for a graphical display to pimp up the visualization a little. I select the bar display control element for this. In the Properties window, I now enter the tag to which the display bar refers. In this case, this is again the temperature value. Now I enlarge this display and specify with alignment in which direction the bar should run with increasing values, namely to the right. I choose a light blue as the bar color. But I also want the bar color to change if the value is too high. I therefore activate Properties for Swell in the Attributes group. The complete bar should turn red when a limit value is exceeded, that means full change. Speaking of limit values, below I specify the limits for the display range. The bar should display a temperature between 0 and 40 degrees. I also want to have a frame around the entire display. I select a dark gray as the color for the frame, and the frame should be slightly thicker. Now I specify the color of the bar when the limit value is exceeded, in this case red. And the limit value should be 30 degrees Celsius. Okay, the bar is now parameterized and I drag it to a suitable position on the start screen. My temperature display is now complete, the only thing missing is the voltage display. I make it easy for myself. I select everything I have created so far, duplicate it and place everything exactly below it. Now the values in these copied elements just need to be adjusted. Let's start with the text. Instead of temperature in degrees Celsius, I enter voltage in volts. Now for the display of the voltage value, I change the process variable here and take the voltage value. Here, however, I want to display 2 digits after the decimal point, so we change the corresponding value here. For the display bar, we also change the process variable with the voltage value and adjust some other properties. The bar should be green instead of light blue and the maximum value is 10. The color should change to red from 8 volts. That's all there is to it. Now I position the display in the center, save the project and create the code for the web server under Project Environment. Under Target System, I select the web server to which this code is to be transferred. The web server for my controller is also displayed here. I select this and can now create a connection to it with Connect. By clicking on Project, the project code is now transferred to the web server of the control unit. Once the project has been transferred, we can close the project transfer window and open a web browser to view the results. We enter the IP address of the controller as the URL, in our case 192.168.0.101, followed by a colon and the port number of the Visu web server 65300. The visualization now appears and we can see the values for the temperature and voltage. I'll quickly switch to full screen mode and then test whether the measured values from CODESYS are transferred and displayed correctly. To test the functionality, we can change the values on the starter kit. First, I rub the temperature sensor with my fingers and I can see in the visualization that the temperature value changes. Okay, that works. Also the color change of the bar when the 30-degree limit is exceeded. Now I turn the potentiometer on the starter kit, and as we can see, the voltage display also changes and the color change at values above 8 volts also works. Okay, in this tutorial you could just experience how to visualize under UOS via PROCON-WEB Embedded System in 6 steps, briefly summarized here once again. Step 1. Installation of the runtime version of PROCON-WEB ES under UOS. Step 2. Installation of the PROCON-WEB Designer on your PC. Step 3. Publishing the process variables in CODESYS. Step 4. Establishing a secure data connection between CODESYS and PROCON-WEB via OPC UA. Step 5. Reading in process variables in PROCON-WEB. And finally Step 6. Creating a visualization with the PROCON-WEB Designer. Thank you for your interest. See you.